Hi guys. Today we're going to be getting into the code of building the Ethereum trust fund or trustless fund. We're going to start off with the Solidity portion. So let's get into it. To start off, we're going to create a Solidity directory. So we're going to do make dir make dir Solidity. There we go. And I'm just using VS Code. This is a completely empty project. I do have the README here, but you can start off with a completely empty project, no problem. So yeah, Solidity inside the Solidity folder. So just change directory into Solidity. Inside here, we're just going to run npm init. That initializes a package.json. We're going to call it Solidity version, a trustless fund. Just call it a trustless fund project. Entry point is fine. Test command, not important. Repository, not important. Keywords. I'll add my name. You can add yours if you like. The license, not important to me. And yes, this is okay. Perfect, we have a package.json. Okay, so next is we're going to run npm I save-dev Hardhat, and that's just going to install Hardhat for us. Hardhat does all the heavy lifting of deploying the contract. Makes our lives very easy. While we wait, there are some other tools. You can use Remix. That's a fully online contract editor. Allows you to deploy smart contracts as well. And then once that's finished, there we go. We're going to do npx hardhat init. That will initialize Hardhat. I always go with TypeScript. The root is fine. Git ignore. Yes, that's fine. That is fine. We'll just wait for that to boot up. Cool. Okay, perfect. All right, so that's pretty much everything. We're now set up with the default lock project. Next, we're actually going to want to work on some environment variables. So let's create a new file here, call it .env. Inside this .env file, we're going to go to Infura. So we can ignore these for now. So let's go to infura.io, check this out. I'll just sign in. So I'm going to set up some environment variables. You guys can just ignore this. After the video is over, I'll take them down. But you guys will at least know how to go through the process. So you guys are just going to go through this process of creating a new API key once you get to Infura, the Infura dashboard. And then once you're finished, you'll be able to check mainnet and Amoy. And from there, you'll be able to copy this key here and then add it to, I'll show you real quick. So once you do that, you want to create a variable here for Amoy RPC provider. You're going to replace this. So copy this, and you're going to place that right there. And now we're set up with Amoy. So that is important so we can communicate with the blockchain. One second. And I will also create, while we're at it, the Polygon RPC provider. And I have that right here. It's the same format, so we just use Polygon and Fura, and then we can just paste the same key here. So that's that. Pretty straightforward. And then next step is we're going to need to add Amoy to MetaMask. So go to a MetaMask. We're going to want to click the network dropdown, and you guys will not have this testnet here, so we're going to add test network. You're going to click add network manually, and then you can add whatever you want. It could be Polygon Amoy or just Amoy. And then you're going to add the RPC URL. So you grab that RPC URL here, and then you can paste that right here. But I've already done it, so you can go through those steps. Chain ID should be auto added once you have the RPC URL, but it's always, for Amoy, it's always going to be, what is that, 80,000? Yeah, 80,002. And then the currency signal, again, should be, see, once that's picked, it automatically picks it for you, so it'll be Matic. Awesome, so that is that. Next step is going to be so we need a MetaMask account for this as well. This is for deploying the smart contract. So go back to MetaMask, go here, click add account or hardware wallet, click add new account. I'm just going to call it test trust fund account 2. I've already created a couple, so I'm just going to call it 2. This should be fine. And that's pretty straightforward, but you're also going to want to get the private key of this, as well as the address. First, I'll just copy the address and then paste it in here. Under the variable is not too important. And then you're going to go through this. You're going to click account details. You're going to click show private key. It'll give you the private key, and then you'll paste it right here. And the variable that we have been working with is this, and you'll just paste that private key right there when you're done. So I'm going to use a different wallet, but you guys will have that all set up. Once that's finished, you're going to want to go to an Amoy faucet. You can just Google Amoy faucet. I have had some luck with, I think it's this one. Yes, so this one has been pretty good to me. You click continue, you add the wallet address that you create here, and it will give you 0.5 Pol or Matic. So yeah, pretty straightforward. Once that's done, we're also going to need, so I have the variable set as Etherscan API key. It probably would be better named Polygon scan API key, but I'm just going to keep it there for simplicity because I've done quite a bit of fiddling with this project. Okay, so the way we get this API key is we go to Polygon scan, we sign in, and then go to API keys. You can also, I think, find it here as well. So either way, go there, and then you can add an API key, create one, and then use that. So I already have one. I will use that, and yeah, that's that. I'll be back in a second. All right, so now that we got the .env file all set up, we can get started with the smart contract itself. So we can scrap all this. I'm just going to rename it to trust fund, and then I'm going to remove the whole thing. Well, how about I just clear out the body and then call this trust fund? Perfect. So with that, I also like to add an author, just because that is fun. So for me, I just have my name. You can add yours. All right, perfect. All right, so let's get started. So the basic idea of this contract is to keep track of deposits. And deposits are going to be a struct called deposit. And they're going to be a uint256. And that will contain the deposit ID. The deposit ID is important so we can keep track of deposits when we're adding or removing. And you'll see later on why that's important. And then we're going to have an address, depositor, and then an address for the beneficiary, and then a uint256 for the amount that's being deposited, and uint256 for the withdrawal date. All right. Next, we're going to have a uint256 here for the it's going to be the deposit count, but this will help us have a unique deposit ID. So every time anyone deposits anything, it'll increment the count, and that'll allow us to have a unique deposit ID for every single deposit in a smart contract. And then we're going to have a mapping 256 to deposit, and this is going to be a mapping from well, actually it's going to be private. It's important for this to be private because we don't want anyone to know who owns what. So this will keep it private. There's also the internal keyword, but that would be a vulnerability if we had internal, because then any other contract that inherits from this smart contract could actually see what is held for each individual user. So I'm just going to add a little comment right here, and then a little comment right here as well. You don't have to add these if you don't want. And then we're going to have another mapping between the address of the depositor. Well, it could be the depositor or the beneficiary. And that'll be the deposit beneficiary to a uint256 array, which will contain the deposit IDs. So this is to keep track of who owns what. So, it'll be a mapping, so, of their address to the deposits that they own. And this will be, this will be permanent. We're not removing any items from this. All we're doing when someone withdraws funds is we reduce the deposit amount to 0. So that is the game plan. And we're also going to need some events here as well. For funds deposited, 256, deposit ID, address, text. One second here. All right. Depositor, indexed, beneficiary and withdraw date. So these are not nice to have. This is indexed so that we can search through the logs later to figure out who has deposited funds and who has been the beneficiary of some funds. And then funds withdrawn, uint 256, deposit ID. Next. And 256. Amount. Perfect. And then now we can start on the function to deposit funds. The interesting bit. So deposit funds is going to take an address, the beneficiary, a uint 256 with a withdrawal date, and it is going to be external and payable because we want to be, well, we have to be able to actually add funds to this, so that's what the payable keyword is for. And external means that this function can be called outside of the smart contract, not just inside by other functions within the smart contract. But external is different from public in that a public function is able to be called both externally and internally, but an external function is only able to be called externally. And from what I understand, that gives us a small gas optimization. All right, so inside this function, we're going to say beneficiary is not equal to address 0. And this is important because we want to make sure that no one is sending any money to the 0 address. This isn't too much of a concern, but it's nice to have. Because later in this logic, we are going to allow anyone that deposits funds to be able to withdraw those funds. So a depositor can withdraw funds regardless of the withdrawal date. So they can get their money back if they would like, and then create a new deposit with a different date for their beneficiary. So that'll allow them to make changes and update the amounts that they're giving to their beneficiary or the dates if they would like. So this isn't too much of a concern, but it's nice to have. All right. And the next is we could add that the withdraw date we could add this. It's not absolutely required, but another nice to have to make sure that the withdrawal date is in the future. This could help out the user a little bit. All right, and now we get to the message.value, which is given to us by payable. And this check is to make sure that the amount is greater than 0. It's an important feature of the smart contract. We don't want to be creating any deposits with 0 funds. That would be no fun and a waste of gas. And here we're going to increment the deposit counter. This is pretty crucial. Missed an S here. Deposits by ID. Counter equals deposit. We're going to add the deposit ID. Slight typo. It should have been deposit counter. Okay. No, that's fixed. Depositor is going to be the message.sender, and the beneficiary is going to be the beneficiary that's passed in, and then the amount is going to be message dot value, and then the withdrawal date is going to be the withdrawal date that's set. Perfect. And then next we need to check if the beneficiary is message.sender, deposit IDs by address. So if the beneficiary is the same as the message.sender, we only want to update this once, else we do need to keep track of it in two places. So deposit IDs by address, sender, yes, and then we're gonna push, you know, I actually just realized I should write this in a different way. I'm just gonna put this here, and instead, to make this a little cleaner, I'm just gonna do not equals, and then I'm going to add this. Yes. Okay. All right. That simplifies logic a little bit. Now we need to emit funds deposited and deposit counter, and then I'll just add all of these things. I'm not going to type this one out. Perfect. Okay. Next step is we're going to add a way to withdraw funds. Withdraw funds. We'll take a uint 256 with a deposit ID. It's going to be another external function. All right, on this one, we're going to have deposit. We're going to keep this in storage. Deposit equals deposit by ID, and then deposit ID. So this is our deposit. We're going to add two require statements. These require statements will prevent withdrawing if the amount is 0, and they'll also prevent it if you're not either the beneficiary or the depositor of the funds. Now we're going to check if the sender is the same as the beneficiary, then we want to check to make sure that the timestamp is past the withdrawal date. So that is important. It's an important require. And then if it is, then we're all good to go, and we can set the amount equal to 0. And then we can send that out, pay it, and emit with funds withdrawn. Perfect. All right, so just 3 more functions here. This next one is called get my deposits, and it's going to be external, view only, and returns the deposit or an array of the deposits. So what we're doing here is we're getting deposit IDs by address with the sender, and then we're creating an array of my deposits and then adding those to the deposits array, and then returning the array of deposits. So pretty straightforward. This is helpful because on the front end, it's convenient to have a list of deposits. And there are two other functions that we're going to add. This one is a function to retrieve deposits for a specific address. So that'll allow us to get deposits for a specific address. Yeah, 1 second here. Deposits for address. I just realized there is a vulnerability, which I will let you guys find later if you want to point it out. But it's right there. Okay, and then so this function is just getting the deposit address. It's not a big vulnerability, but your funds are safe. It's just that, well, you'll see it if you see it. Get deposit details. This just returns deposit details if you have the deposit ID, which is straightforward. And there's a requirement that you have to be the beneficiary or the depositor. Oh, actually, never mind. Oh, okay, all right. You know what? I'll tell you what I was thinking. So I thought that you could get the deposit details with the address, but I did actually think about this. So you're actually not getting deposit details. So that's why there's not a vulnerability. I thought there was a vulnerability, but there's not. So your deposit details are still obscured, and that's because here we're only returning the deposit ID, and then here we're requiring, before we send the actual details of the deposit with the deposit ID, we're requiring that you're either the message, or we're requiring that you're either the beneficiary or the depositor of the deposit. So there we go. Everything is in its place. All right, perfect. So that smart contract is looking really good. Next, we can try to compile this. But before we do that, I'm going to make sure to update this package.json. So let's do that real quick. So we do want to use .environment at some point in the future. And then we also want these list of commands to build, clean, test, deploy, and verify the smart contract. So here we just want to build it to make sure everything works. So we're going to do npm run build. Let's see if that works. All right, compilation failed. Let's see. All right, looks pretty like a pretty straightforward error here. Line 36. Yep, no dangling commas allowed in Solidity. All right, next issue. Deposits by ID. I think that is what I meant. It says it's on line 31. Yep, perfect. Funds deposited, expected 5. Okay. So let's make sure that this is right. I think we missed one of the properties here. So it looks like we missed the amount right here. And that's the issue. npm run build. Another issue. Relevant source parts here spans across multiple lines. Okay, all right, I've never seen this one. Part starts here and spans. Let's see here. Oh, I see. I keep having little typos. Okay. Amazing. It compiled. All right. Cool. So now that that has compiled, we can run a couple tests for it. I am going to rename this file trust fund, and then I'm going to just copy and paste my file. All right, and I'll walk you through everything that's happening here. So in this test file, we're describing trust fund tests. This is just a comment that gets logged out. We are calling a asynchronous setup function to get the owner and other account, which we do need to set up in the Hardhat config. So I'll show you guys how to do that. And then after we get the owner and the other account, we get the trust fund contract and deploy it. We get the contract. So, or we return the contract. So here we call setup. We get a timestamp and we add it in the future so that when we add a couple seconds just so that when we deposit funds, the timestamp is in the future. And so that requirement that we added earlier gets approved. After we deposit funds, we wait for one confirmation. Then we get my deposits. We get the deposits. We grab the amount. And we check that it's the same. So it's a simple test to just check that what we added is there. Next test is to test whether the funds can be withdrawn. And here we're having an issue where this does not exist on type withdraw funds. Oh, maybe oh man. Another typo. There we go. Okay. So yeah, this again adds 5 seconds, or the other one we had 10, now we're at 5. And then we're waiting, and then we're just setting a timeout for that time to pass. And then we're getting the deposit funds. Once we get it, we can get the deposit ID and then withdraw that deposit ID and then wait. And then we check that it's a valid transaction and we got it back. All right. So that pretty much sums it up for the tests, but we do need to add another account, or we need to add the Hardhat config. So inside this file, a couple of things. First of all, we'll do some environment variables here. These are pretty straightforward. Don't need to talk about this too much. Some gas multipliers, gas limits. This is to prevent the transaction from becoming too expensive. There is an import here for test wallets. So I've created a new file called test wallets.ts. In here, I will just paste everything I have here. So we have that account secret key, which we added to our environment variable with a balance. And then we have the Hardhat accounts, which are auto-generated with the secret key. So these are local Hardhat accounts that we can use to test things. All right, perfect. Once that's done, we need to check this. Make sure this is saved. Can't find module. Can't find module test wallets. Let's see here. Just make sure the config at the top is right. Not sure why that wasn't working. Test wallets. Okay. Anyway. All right. Solidity version is correct. Next is Etherscan. This is important for verifying a smart contract. So API key, or Etherscan API key that we added earlier. We have to add a custom chain. This is because there's no built-in logic right now for Amoy, so we have to add it. Polygon Amoy, chain ID 8002, and then URLs. We can paste in these. Perfect. And then the rest of these we can just paste in. So for Polygon Amoy, we have the RPC provider, localhost. We don't need an RPC provider. And then we just map the accounts that we imported up here. Gas prices are set. Gas multipliers are set. We have the chain IDs passed in. So we're all good to go. All right, and then next, to deploy this, we're going to rename this again to Trust Fund. And then we're going to use the default to deploy it for us. Okay, so that should be just about everything. npm run test should work at this point. Couldn't find .environment. Okay, yes, so it's because we haven't installed it. We did add it to the package.json, but we didn't install it. So I think that should work. All right, one down, another one to go. Perfect. All right, now we can do npm run deploy Amoy. Oops. npm run deploy Amoy. Yes. Could take a couple seconds. All right, nice, that's deployed. We can take a look at this smart contract. Go over to not Polygon scan, but it's got to be the Amoy.Polygon scan. Paste this in, and the contract is deployed. Perfect. However, it's not verified. There's no check mark here. We just have the bytecode. So we can do that pretty easily with this command. Verify. Looks like that worked. And if we refresh this, we can see that it's verified. And we can see that the smart contract and all the source code shows up with the API. So that is perfect. That means everything is working. And we can deploy to Polygon mainnet in the exact same way. I will say this, I don't think, well, we did go over adding funds briefly with, we went over briefly adding funds to your wallet that you created with Faucet, but we did not go over doing that on Polygon. Polygon, you'll have to use Realmatic if you're going to deploy on Polygon. So to run the deployed Polygon command, you're going to have Realmatic in the wallet, which you can buy on many different places, many different exchanges, like Coinbase is one of them. So yeah, that's pretty much it for the smart contract. It's now deployed live. The next video is going to be on the front end for this, and I will see you guys there.